Lesson: AI in cloud-native environments. The integration of artificial intelligence into cloud-native environments is a pivotal advancement in the field of technology, enabling organizations to leverage the scalability, flexibility, and cost-effectiveness of the cloud while enhancing AI capabilities. This lesson delves into the symbiotic relationship between AI and cloud-native architectures, emphasizing actionable insights, practical tools, frameworks, and step-by-step applications tailored for professionals seeking to excel in this domain. Through practical examples and case studies, this lesson aims to equip learners with the knowledge and skills to address real-world challenges and enhance their proficiency in cloud-native AI environments. Cloud-native environments, characterized by their use of microservices, containers, and orchestration tools such as Kubernetes, offer an ideal platform for deploying AI applications. These environments provide the dynamic scalability required to handle the intensive computational demands of AI workloads. For instance, TensorFlow Serving, an open-source tool, is optimized for deploying machine learning models in production. It integrates seamlessly with Kubernetes, allowing for efficient load balancing and scaling of AI models across distributed cloud resources. One of the primary advantages of cloud-native AI is its capacity to facilitate continuous integration and continuous deployment pipelines. This is crucial for AI applications, which often require frequent updates and iterations. Tools like Jenkins and GitLab CI/CD enable automated testing and deployment of AI models, ensuring that updates can be rolled out rapidly without disrupting service. This continuous delivery model is particularly beneficial in environments where AI models must adapt quickly to changing data patterns or user demands. In cloud-native environments, data management is a critical aspect that directly impacts AI performance. Data lakes, such as those offered by Amazon S3 or Google Cloud Storage, provide scalable storage solutions capable of handling vast datasets necessary for training AI models. The integration of AI with these data lakes can be facilitated by Apache Spark, an open-source distributed computing system. Spark's machine learning library, MLlib, allows for efficient processing of large-scale datasets, making it an excellent choice for developing and deploying AI models in cloud-native environments. Security is a paramount concern when deploying AI in cloud-native environments. The distributed nature of these environments increases the attack surface, necessitating robust security measures. Service meshes like Istio provide a solution by offering fine-grained security policies and monitoring capabilities. Istio can enforce authentication and authorization policies, encrypt data in transit, and provide comprehensive telemetry data, ensuring that AI applications remain secure while benefiting from the scalability and flexibility of cloud-native architectures. Moreover, the role of AI in enhancing the management of cloud-native environments cannot be overstated. AI-driven automation tools such as Ansible and Terraform leverage machine learning algorithms to optimize resource allocation, predict failures, and automate complex workflows. By analyzing historical data and identifying patterns, these tools can proactively adjust resource provisioning, ensuring optimal performance and cost efficiency. A notable case study illustrating the effectiveness of cloud-native AI is Netflix's use of an AI-driven recommendation engine. Netflix leverages Amazon Web Services to host its microservices architecture, utilizing Kubernetes to orchestrate containers running AI models. The recommendation engine processes petabytes of data daily, analyzing user preferences to deliver personalized content suggestions. By adopting a cloud-native approach, Netflix can scale its AI workloads dynamically, ensuring seamless user experience even during peak traffic periods. In healthcare, the application of AI in cloud-native environments has led to significant advancements in medical imaging analysis. For example, Zebra Medical Vision utilizes Google Cloud's AI and machine learning capabilities to analyze medical images, identifying potential health issues with high accuracy. By deploying their AI models on a cloud-native platform, Zebra Medical Vision can rapidly scale their analysis capabilities, providing timely and accurate diagnostics to healthcare professionals worldwide. The financial sector also benefits from AI in cloud-native environments. Banks and financial institutions use AI algorithms to detect fraudulent transactions in real time. By deploying these algorithms on cloud-native platforms, organizations can leverage the elastic nature of the cloud to process vast volumes of transactional data efficiently. This approach not only enhances the accuracy of fraud detection, but also reduces operational costs associated with maintaining on-premises infrastructure. Despite these advantages, deploying AI in cloud-native environments presents challenges that professionals must address. One significant challenge is the complexity of managing distributed systems. Tools like Prometheus and Grafana provide monitoring solutions that offer real-time insights into system performance, enabling teams to identify and resolve issues promptly. By incorporating these tools into their cloud-native AI strategy, organizations can maintain high availability and reliability of their AI applications. Another challenge is ensuring data privacy and compliance with regulations such as GDPR or CCPA. Privacy-preserving techniques, such as federated learning and differential privacy, allow AI models to learn from data without compromising individual privacy. Implementing these techniques in cloud-native environments requires a deep understanding of both AI and cloud technologies, underscoring the need for skilled professionals in this field. In conclusion, the integration of AI into cloud-native environments represents a transformative approach to developing and deploying AI applications. By leveraging tools and frameworks such as TensorFlow Serving, Apache Spark, Istio, and Ansible, professionals can harness the full potential of cloud-native architectures to deliver scalable, flexible, and secure AI solutions. Through practical examples and case studies, this lesson has highlighted the actionable insights and strategies that professionals can implement to address real-world challenges and enhance their proficiency in this domain. As the demand for AI-driven solutions continues to grow, expertise in cloud-native AI environments will become increasingly valuable, positioning professionals to lead in the development of innovative and impactful technologies.